current grounding system with separately grounded disconnect panels and a near 200 amp panel with its own grounding system is not compliant with the National Electrical Code (NEC). According to NEC 250.53 A1, all grounding electrodes within the grounding system must be bonded together to form a single electrode system. NEC 250.53 A2 requires that the grounding conductor from each building or structure to the grounding electrode system must be connected to the common grounding electrode conductor where it enters the building or structure. Currently, each disconnect panel is grounded separately to its own ground rod, creating isolated grounding systems. The newer 200 amp panel also has its own grounding system without bonding to the other panels. To comply with NEC requirements, all four grounding systems must be bonded together. There are a couple of options for making the necessary changes. The first option involves bonding ground rods directly. Install a number 4 bare copper conductor between two of the ground rods. Connect the conductor to the clamps or lugs on each ground rod using an appropriate bonding fitting. The second option involves bonding at the CT can. Extend the number 6 GC from one of the disconnect panels to the CT can. Connect the extended conductor to the grounding busbar or lug inside the CT can. Place a bonding jumper between the CT can grounding busbar and the ground rod for the newer 200 amp panel. There are also additional considerations to keep in mind when upgrading the grounding system. Firstly, make sure the bonding conductor is sized according to NEC Table 250.66. Secondly, the bonding point should be accessible for inspection and maintenance. Thirdly, all connections should be tight and free of corrosion. It is important to adhere to NEC standards to ensure safety and prevent electrical hazards. The NEC provides specific guidelines for grounding and bonding electrical systems, including the size and type of grounding conductors, the methods of connecting grounding electrodes, and the requirements for bonding different parts of the electrical system together. When dealing with an 800 amp service and multiple disconnect panels, it's essential to have a grounding system that is both effective and compliant with the NEC. The grounding system's primary purpose is to provide a low impedance path for fault currents to return to the source, allowing overcurrent protection devices, such as circuit breakers or fuses, to quickly clear the fault. An improperly grounded system can result in dangerous voltage on metal parts, increasing the risk of electric shock and fire. In the situation described, with 3 older 200 amp disconnects each grounded to a single ground rod via number 6 GC and a newer 200 amp panel with its own separate ground rods, the key issue is the lack of interconnection between these grounding electrodes. The NEC mandates that all grounding electrodes be bonded together to form a unified grounding electrode system. This ensures that all parts of the electrical system are at the same ground potential, minimizing voltage differences and providing a reliable path for fault currents. To rectify the existing situation, there are a couple of approaches that could be taken to establish proper bonding. One option is to directly bond the ground rods together using a number 4 bare copper conductor. This involves connecting the ground rods associated with the older disconnects and the ground rods for the newer panel with the number 4 conductor, ensuring a continuous, low impedance path between all grounding electrodes. Proper clamps or lugs designed for direct burial application should be used to make these connections. Another option is to use the CT can as a central bonding point. In this scenario, the number 6 GC from one of the older disconnects can be extended to the CT can and connected to the grounding busbar or lug within the CT can. A bonding jumper can then be run from the CT can grounding busbar to the ground rods associated with the newer 200 amp panel. This creates a common grounding point at the CT can, effectively tying together the grounding systems of all disconnects and the newer panel. In either case, it's crucial to verify that the size of the bonding conductors is adequate based on NEC Table 250.66. This table provides guidance on the minimum size of grounding electrode conductors and bonding jumpers based on the size of the service entrance conductors. In this case, with an 800 amp service, the service entrance conductors are likely to be quite large, which may necessitate a larger bonding conductor than a number 4 in some scenarios. The bonding point should also be accessible for inspection and maintenance. Over time, connections can loosen or corrode, compromising the effectiveness of the grounding system. Having easily accessible bonding points allows for periodic inspections and tightening of connections, ensuring the continued reliability of the grounding system. All connections must be tight and free of corrosion to maintain a low impedance path for fault currents. Corrosion can significantly increase the resistance of connections, reducing the effectiveness of the grounding system and potentially leading to dangerous conditions. Regular inspections and cleaning of connections can help prevent corrosion and ensure that the grounding system remains effective. It's also important to ensure that all grounding electrodes are properly installed and in good contact with the earth. Ground rods should be driven deep enough into the ground to reach moisture, and the soil should be conductive enough to provide a low resistance path to earth. If the soil is particularly dry or rocky, it may be necessary to use multiple ground rods or other grounding electrodes to achieve an acceptable level of grounding resistance. In addition to bonding the grounding electrodes, it's also important to ensure that all metal parts of the electrical system are properly bonded together. This includes metal enclosures, conduit, and equipment grounding conductors. Bonding these parts together creates a low impedance path for fault currents, helping to protect against electric shock and fire. The equipment grounding conductors should be sized according to NEC Table 250.122, which specifies the minimum size of equipment grounding conductors based on the rating of the overcurrent protection device protecting the circuit. All metal enclosures and conduit should be bonded together using bonding bushings or other approved methods. This ensures that there is a continuous, low impedance path for fault currents throughout the electrical system. Grounding and bonding are critical aspects of electrical safety. By following the requirements of the NEC and ensuring that all parts of the electrical system are properly grounded and bonded, it's possible to minimize the risk of electric shock and fire and create a safer electrical environment. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are based on extensive research and testing and are designed to provide a safe and effective grounding system. It's essential to consult the NEC and other applicable standards when designing and installing electrical systems to ensure compliance and safety. In summary, the existing grounding system is not legal because the grounding electrodes are not bonded together to form a single electrode system. To comply with the NEC, all 4 grounding systems must be bonded together using either a direct connection between the ground rods or a connection through the CT can. The bonding conductor must be sized according to NEC Table 250.66. The bonding point must be accessible for inspection and maintenance, and all connections must be tight and free of corrosion. By following these steps, it's possible to create a safe and effective grounding system that complies with the NEC and protects against electrical hazards. The grounding electrode system includes the ground rods and any other electrodes that are used to connect the electrical system to the earth. The grounding electrode system provides a low impedance path for fault currents to return to the source, allowing overcurrent protection devices to quickly clear the fault. The grounding electrode conductor (GEC) connects the electrical system to the grounding electrode system. The GEC should be sized according to NEC Table 250.66 and should be installed in a continuous length without splices or joints. The bonding jumper connects different parts of the electrical system together, such as metal enclosures, conduit, and equipment grounding conductors. Bonding jumpers help to create a low impedance path for fault currents and minimize voltage differences between different parts of the electrical system. The equipment grounding conductor (EIC) connects the metal parts of electrical equipment to the grounding system. The EGC should be sized according to NEC Table 250.122 and should be installed in the same raceway or cable as the circuit conductors. Grounding and bonding are essential for electrical safety. By following the requirements of the NEC and ensuring that all parts of the electrical system are properly grounded and bonded, it's possible to minimize the risk of electric shock and fire. Consulting with a qualified electrician is recommended to ensure that the grounding system is installed correctly and complies with all applicable codes and standards. A thorough understanding of grounding and bonding principles is crucial for anyone working with electrical systems. The proper installation and maintenance of grounding systems can help to prevent electrical hazards and create a safer working environment. The NEC is a comprehensive document that provides detailed guidance on all aspects of electrical safety, including grounding and bonding. It is essential to consult the NEC when designing, installing, or maintaining electrical systems to ensure compliance and safety. Furthermore, it is imperative to recognize the limitations of this information. While it provides general guidance based on the NEC, it cannot substitute for the expertise of a qualified electrician or engineer. Electrical codes and regulations can vary depending on the location, and specific project requirements may necessitate tailored solutions. Always consult with a licensed professional to ensure that the grounding system meets all applicable codes and regulations and is appropriate for the specific application. The information provided is intended for educational purposes and should not be considered a substitute for professional advice. Electrical work can be dangerous, and it is essential to take all necessary precautions to protect yourself and others from electrical hazards. Always energize circuits before working on them, use appropriate personal protective equipment, and follow safe work practices. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Remember, safety should always be the top priority when working with electrical systems. Understanding the importance of proper grounding and bonding is a crucial step in ensuring electrical safety and preventing potential hazards.